Okay, we're going to name some polyatomic ions, or polyatomic compounds. So you have a list of the polyatomic ions. I have another list too. Okay, these are the polyatomic ions. And remember that they act as a single unit. They have a single oxidation number, and they have a single name. Okay, the rule still applies. So if there's a transition metal, then there's a Roman numeral in the name. So we'll check for that also. Start here with number 3. Check and see if aluminum, is aluminum a transition metal? Well, there's aluminum. Aluminum is not a transition metal. So this does not get a Roman numeral. So I can just name it using standard rules following the list of polyatomic ions also. So the name here is aluminum. And Cn is a polyatomic ion. It's in parentheses, just like I like to see it. So Cn is right there. Okay, might be different on your list, but it's the same polyatomic ion. This is cyanide. So this is aluminum cyanide. Now you don't change anything for that second, that negative ion. You don't change anything. You leave the name exactly as it is. So cyanide stays as cyanide. Chromate stays as chromate. You don't change anything on these polyatomic ions when you're naming them. Number 8, check and see if calcium is a transition metal. Calcium's right here, not a transition metal, so this doesn't get a Roman numeral in the name. So I write the name for Ca, which is calcium, and find C2H3O2 on my list. It's right here. It's acetate. Acetate. And remember, don't change the ending when you do these polyatomic ions, or when you're naming these polyatomic compounds. This is calcium acetate. Okay, number 12. Check and see if iron is a transition metal. Yep, there it is. It's a transition metal, so this guy is going to get a Roman numeral in its name. You do the same thing. You uncrisscross the the subscripts and use them as oxidation numbers. So that'll be +4 there. And take that, there's nothing there, so we assume it's a 1, so -1. Same rules, we do this the same way. So we go and find cyanide on our list of polyatomic ions and check its oxidation number. Is cyanide -1? Yeah, cyanide always has that -1 oxidation number. And remember, if the negative ion is correct, that means the positive one's correct. So the way to name this is going to be iron 4 cyanide. Okay, let's try these that are kind of mixed up. Okay, we just named iron, so we know that iron is a transition metal. So I need to uncrisscross that 3. Put it up here as a +3. There's no number there, so we assume it's what? -1. So we'll find bromine. There's bromine. Bromine has a -1 oxidation number. So that means that's right. So that means the +3 is right. So this is going to be iron 3 bromide. Okay, we changed the ending here because bromine's not a polyatomic ion. We don't change it if it's a polyatomic, but it's not a polyatomic, so we have to change the ending to IDE for that binary compound. Number 6. Check and see if silver is a transition metal. Well, yes, silver is a transition metal, but remember, silver, zinc, and cadmium are our exceptions there. Silver always has a +1 oxidation number, so we don't need to worry about it. It doesn't get a Roman numeral. So we can just name this thing silver oxide. Okay, and that last one, let's check aluminum. Here's aluminum. It's not a transition metal, so there won't be a Roman numeral in this name. This thing's just going to be plain old aluminum. Don't forget to change the ending, bromide. Okay, good luck.